Assalamualaikum, kita sambung lagi soalan nombor 17 untuk SPM trial paper tahun 2011 negeri Johor, paper 1. Okay, nombor 17, gradient of the curve y equal to 2x squared plus x minus 1 at a point A is perpendicular to the straight line 5y equal to minus x. So find the coordinate of A and then the equation of the tangent to the curve at point A. Alright, let's go and cut this question somewhere else. Let's do that again. Okay, this question carries 4 marks, quite significant. Let's paste it here, our paper. Okay, that's our curve. Well, let's draw our curve for a while. Then its shape is roughly like this. Okay, this is the curve y equal to 2x squared minus x minus plus x minus 1. Alright, so this is the curve. And then we have a point A with a tangent. Let me just draw a different color with tangent of at point A, something like this. Oops. Okay, we name that as point A. And this is the tangent to y to 2x squared plus x minus 1 at point A. Alright, we just write there with gradient. With gradient not known yet, we call it a gradient M1. Okay, that's the reason for that. Okay, then we have that tangent is perpendicular to line 5. Looks ugly. 5y equal to minus x, and we say this has gradient M2. Okay, so we have M1, we have M2. So y is equal to minus 1 over 5x. Therefore M2 is minus 1 over 5. Alright, why? How do I get that? That this number here, the coefficient of x, whenever we have only single y on the left, that is going to be the gradient of the line. Okay, so for two perpendicular lines, M1 multiplied with M2 is minus 1. This is the law of two perpendicular lines. If you have two perpendicular lines, the product of the two gradients are negative 1. So now we can find the gradient of the gradient of the tangent to that curve. M2 is known. So M1 times minus 1 over 5 is equal to minus 1, and as such M1 is 5. Okay, that's the gradient. So now we can find the gradient of the curve at A, which is already 5, but we need to find the general term of the gradient. So let's take a look at the curve and we differentiate it. Y is 2x squared minus x plus x minus 1. Then dy over dx. This is the general term. This is the equation of the gradient of the curve. Okay, And let's page down a little bit. At point A, dy over dx is 5, and as such 4x plus 1 is 5, and 4x is 4, and x is 1. Okay, and then we plug it, we put x equal to 1 into the equation of the curve, which is y 2x squared plus x minus 1. Then y is 2 1 squared plus 1 minus 1, so 1 minus 1 is gone. So now it's left with 1 squared with 1, then multiply with 2, then it's 2. Therefore the point A has coordinate what is the value of x? Is 1, and the value is y 2. This is the answer for question A. Alright, so this is A. B, the equation of the tangent to the point curve. Alright. Then we can use the gradient formula. The tangent to the curve, I'm just writing it down, quite lengthy here, but because I want to make sure that the equation is easier to understand to the coordinator, as if coordinator have no idea what we are trying to do. Okay, so the tangent to the curve, I'm trying to make it complete. At point A, 1 2 has gradient of 5. Okay, and such, then we say then y minus 2 equal to x minus 1 is equal to 5. Okay, this is the gradient formula. I don't know whether or not that is the official name for that, but I just call it the gradient formula. Then y minus 2 is equal to 5x minus 5, and finally we get the equation of the tangent. Y is equal to 5x minus 3. So this is the equation of the tangent to the curve at point A. Alright, let's move on. Next question. Okay, given that y, alright, let's just go and cut it. Okay, yeah. And again we paste it at our favorite location, since I'm never gonna have enough space there. Okay, given that y is equal to 4r plus 1 squared and x is to r, dy dx in terms of x. Alright, I can see that there's quite a number of ways to do this. How many points does this one carry? 3 points. Okay, not bad. Okay, let's go into I just show you a few ways to do that. Okay, so I'll show you the first one. Y is 4r plus 1 squared, but x is 2r. So what I'll do is that I'll just replace this expression here with the expression of x. Alright, and as such, I just call this equation 1 and I call this equation 2. Okay, and then put x equal to r into, well, into 1, and then that will become y equal to 2x plus 1 squared. So dy dx is going to be 2, reject 2 over here, and then just well, I just write 2x plus 1, and then differentiate the one inside the bracket and become 2. Then the answer is 2x plus 1. So this is the answer. The other way to do that is I just draw a line from this step. I can also do this. Y is equal to, I just open the bracket here and square them. Okay, 4x squared plus 4x plus 1. So dy dx is going to be 8x plus 4, okay, which is still the same with this, because I can just do that, factorize it, and I put 4 inside, then 2x plus 1 inside. Okay, so still the same answer. And there is a second way to do that. Not the second way, but rather the third way. Since we have, let me just label them. This is 1, this is 2. I show you the third way. So y is equal to 4r plus 1 squared, and as such dy over dr. Okay, I just do intermediate one. Intermediate differentiation. Dr is 4r plus 1, 4. So that is equal to 8. 4r plus 1, right? And then we have x equal to r, and dx over dr is 2. Is 2, yeah. Then push down so that I have more space. Not that far. Then dy over dx is equal to dy over dr multiply with dr over dx. Okay, so that, why do I do this? So that I can just cancel out dr over dx and become dy over dx, right? So that equals to 8 4r plus 1 time, well, dx over ds 2, so we multiply with half then. Okay, because this is just the dx over dr is 2, and then dr over dx, then we just reciprocal it, it become 1 over 2. But 4r is equal to 2x, okay, because we want to get rid of that 4r there. So well, 2 and 8 and 2 over here, we cut it up, become 4. Then 4r 2x, and become 2x plus 1. So still have the same answer. Okay, how cool is that? Let's go to the next question. Okay, that's all for question 18. Next question, number 19. Alright, let's go and cut. This question carries 3 marks. Put it at the very end. Okay, given that y is equal to 8 over x plus 1, express the approximate change of y in terms of x, in terms of m, and when x changes from 3 to 3 minus m, where m is a small value. Okay, let's find dy dx first. So y is 8 over x plus 1, or equal to 8x plus 1 raised to the power of minus 1. Then dy over dx is going to be minus 8 okay, plus 1, x plus 1 2, then multiply with 1. That is basically minus 8 over x plus 1 squared. Okay, Then this is also same as writing like this: limit f delta x approaches 0, delta y over delta x equal to minus 8 over x plus 1 squared. This is the more raw form. Okay, then we can write delta y then for limit delta x approaches 0 is equal to minus 8 delta x over x plus 1. Okay, what is x is now equal to 3, and delta x is it changes from 3 to 3 minus m, so it is 3 minus m minus 3, which is equal to minus m. So we just substitute the values. I'm just calling this equation 1. Okay, then put x equal to 3 and delta x equal to minus m into 1. Then limit delta x approaches 0, delta y is equal to minus 8, delta x is minus m over x is 3 plus 1 squared. There is now 8m over 4 squared. 4 squared is 16, right? So 8m over 16, that is actually equal to m over 2. Okay, we got the answer. Cool. Okay, because we have already exceeded 17 minutes, we're gonna meet again in the next video. Okay, see you again. Bye bye.